Let's start with the simplest yet perhaps the most essential question to better understand this entire video. What is testosterone? To keep it very simple, testosterone is a chemical substance. But it's not just any chemical substance, it's a hormone. A steroid hormone to be exact. So, what is a hormone? Or even a steroid hormone? Let's explain the former then the latter. Hormones are like your body's internal messengers, delivering important instructions to keep everything running smoothly. Think of them as tiny chemical signals that travel through your bloodstream, reaching different parts of your body to tell them what to do. They play a vital role in a wide range of functions, from regulating your mood and energy levels to controlling growth and metabolism. So, when we talk about hormones like testosterone, we're referring to powerful substances that help shape both your physical and emotional well-being. So, to sum it all up, or dumb it down, a hormone is like a messenger in your body that travels throughout the body to tell your cells what they should do, or signal awareness towards an event that's happening in the body. There are countless hormones, and each of these many hormones conveys a different message to the cell. Testosterone in specific is a steroid hormone. But before we get to that, let's talk about another hormone which is also a steroid hormone for the sake of example, and also, because cortisol can have relationships with testosterone. So, cortisol is the hormone of stress. It is produced by the adrenal gland. When you experience a lot of stress, your body produces more cortisol, and that cortisol then goes to your cells to inform them that your body is under stress. This naturally has various consequences. For example, cortisol increases blood pressure, which in turn ensures more blood flow to organs that need it during periods of stress. Now that you know what a hormone is exactly, without shoving around buzzwords, I can continue to explain what testosterone itself is precisely. Testosterone is an androgenic steroid hormone. Okay, another buzzword, steroids. Let's explain that. Steroids are used in colloquial English to commonly refer to hormonal replacement or enhancement therapies that many people often recklessly take to accentuate their muscle mass, improve mood, quote-unquote reverse aging, increase virility and sperm count, and so on. Which are all outcomes of higher testosterone, but let's speak about that later. What steroid actually means, and the context we're using that word in today, is the name of a grouping of hormones based on chemical structure. When we refer to a hormone as being a steroid, what we mean is that they are derived from cholesterol and have a distinct molecular structure, which many hormones will broadly share, thus, grouped as steroids. For example, testosterone, cortisol, etc. Androgenic hormones are also another grouping of hormones. To be classified as one, it would generally need to be mostly responsible and specialized in the development and maintenance of masculine characteristics in the human body, like the primary androgen, testosterone. But there are others too, such as dihydrotestosterone, DHT, and dehydroepiandrosterone, DHEA. We'll only be going into testosterone today. If you'd like us to talk about the other androgens, leave a comment below. Anyway, as we said, testosterone maintains male traits in men. Androgens are also important for women, but that's for later. So, when we're throwing around the term masculine, we really need to narrow down what we're talking about when we say masculine. Think about the difference in size and muscle growth between boys and girls when they are young. Before the age of 12, differences in physical characteristics like strength and height are very small between boys and girls. However, during puberty, this changes completely, because during puberty, the amount of testosterone in a man significantly increases compared to women. This increase in testosterone brings about various physical and even mental changes, also known as sexual dimorphism, characteristics typical of the two different sexes. Some examples of male sexual dimorphism are facial hair. Males typically have more facial hair growth, including a beard, mustache, and sideburns, compared to females. Body hair. Males tend to have more body hair, such as chest hair, arm hair, and leg hair, compared to females. Muscle mass. Men generally have greater muscle mass and strength compared to women, which is influenced by testosterone levels. Adam's apple. The prominence of the Adam's apple, or laryngeal prominence, is typically more pronounced in males due to differences in the size and shape of the larynx. Voice pitch. Testosterone contributes to the deepening of the voice during puberty, resulting in a lower pitch in males compared to females. Body size. On average, males tend to be taller and have larger body sizes compared to females of the same age, Jawline and facial structure. Men often have a more prominent jawline and broader facial structure compared to women, which can contribute to a more masculine appearance. Behavioral traits. While not strictly physical, certain behavioral traits may also be sexually dimorphic, such as aggression, dominance, and competitive behavior, which can be influenced by testosterone levels. To put it straight, a wuss in the mindset is also physically a wuss. These traits vary among individuals and populations, due to many reasons such as evolutionary adaptations and the ancestral lifestyles that led to them. But they represent typical differences between males and females resulting from biological and hormonal factors. For example, the average man produces 5 to 6 milligrams of testosterone daily, while the average woman produces only 0.25 milligrams per day. The reason men produce more testosterone than women are because of the simple fact that men have androgenic gonads and women do not. They have different gonads, ovaries. The testes, which only biological males possess, consist of seminiferous tubes, where spermatogenesis takes place, and on the other hand, our area of interest, the interstitial cells of the testes, basically the cells that lie between the spaces of functional cells of any tissues, are the ones that produce testosterone in this case. In the testes, they are called Leydig cells. These Leydig cells are responsible for the production of testosterone and sperm. In men, the gonads are responsible for 95% of their total daily testosterone production, and the remaining 5% is produced by the adrenal glands. And since Leydig cells are interstitial, it would also mean that sperm production and health are related to testosterone levels. It's a no-brainer, but now you know why. But how does testosterone come to be chemically produced by the gonads and adrenal glands? Well, as we said earlier, testosterone is a steroid hormone, which is a type of hormone produced from cholesterol. The image below will help explain this further. So, if this is the structure, how does testosterone come to be? Here's an image explaining the pathway. You can see in the image that testosterone can be produced in various ways, but it all begins with cholesterol. Cholesterol is the essential building block from which all steroid hormones, including testosterone, are created. However, before cholesterol transforms into testosterone, a series of steps occur. Among the various pathways through which cholesterol is converted into testosterone, the route with the yellow arrows is the most common. Pregnenolone, DHEA, and androstenediol are all prohormones. Prohormones are substances that act as hormones, but are inactive or weak forms of hormones that undergo conversion into active hormones through metabolic processes. The primary role of prohormones is to serve as precursors, building blocks or intermediaries in the synthesis of another hormone within the human body. Prohormones are important in hormone regulation because they provide a reservoir of inactive hormone precursors that can be readily converted into active hormones when needed. Additionally, prohormones may have biological effects of their own, albeit weaker than those of the active hormones they produce, which we'll talk about in the future. The conversion of cholesterol into the various prohormones and ultimately into testosterone is facilitated by various enzymes, which are also highlighted in red in the image. To enable these enzymes to function, minerals, vitamins, coenzymes, and stimuli are required. The stimuli come from other hormone-producing glands and originate in the brain. There are 4 steps. Step 1. Step 1 begins in the hypothalamus, located in the middle of the brain. It is a region responsible for regulating hormone production. In this step, specialized neurons produce a hormone called gonadotropin-releasing hormone, GnRH, which is released into the bloodstream. Step 2. In Step 2, we return to the gonadotropin-releasing hormone, which has by now traveled through the bloodstream to the pituitary gland, also known as the hypophysis, and known as the master gland for its role in secretions that cascade most hormone reactions. This gland is located in the middle of the brain, near the hypothalamus. As previously explained, a hormone is essentially a chemical messenger that instructs cells on what to do. This is exactly what happens here. Gonadotropin-releasing hormone tells the pituitary gland that 2 new hormones need to be released into the bloodstream: luteinizing hormone, LH, and follicle-stimulating hormone, FSH. You can mostly forget about the latter, as it has more to do with the production of sperm than testosterone itself. The focus is on luteinizing hormone in this case. Step 3. Luteinizing hormone travels to the Leydig cells, which were already mentioned earlier. When LH arrives in these Leydig cells, it signals the production of numerous enzymes by binding to specific receptors on their surface. These enzymes, in turn, trigger the release of even more enzymes. Enzymes like CYP11A1 and 17-alpha-hydroxylase. You don't need to remember these complex names, but the important point is that when you refer back to the image illustrating how testosterone is produced, these enzymes are marked in red. These enzymes are produced in the Leydig cells under the influence of luteinizing hormone, and they facilitate the transformation of cholesterol, a precursor molecule, into testosterone, with all the intermediate steps involved. But these enzymes require more than just luteinizing hormone to function correctly. Various nutrients, such as minerals, vitamins, and cofactors, are essential for their proper functioning. In general, before going in detail, vitamin A, crucial for the conversion of cholesterol into the prohormone pregnenolone, it supports the activity of enzymes involved in Leydig cell stimulation. Zinc. Zinc is a critical mineral that serves as a cofactor for several enzymes involved in testosterone synthesis, including CYP11A1 and 17-alpha-hydroxylase. It plays a vital role in the conversion of prohormones into active hormones. Magnesium. Magnesium is another extremely important mineral that supports the activity of enzymes involved in steroid hormone synthesis, including testosterone. It is necessary for the proper functioning of various biochemical reactions in the body. Vitamin B6, pyridoxine. Vitamin B6 is involved in the metabolism of amino acids and is necessary for the synthesis of neurotransmitters and steroid hormones. It supports the activity of enzymes involved in testosterone production. Boron. Boron is a mineral that many may not have heard of, but it is crucial for the enzymes that produce testosterone, as well as other cofactors and coenzymes, like NADPH, ATP, are required. According to Raymond Peat, a PhD in biology at the University of Oregon, additional cofactors are required for the conversion of cholesterol into pregnenolone, such as the active thyroid hormone, triiodothyronine, or more notorious as T3. Triiodothyronine is the hormone that oversees the metabolism, basically saying that the higher your triiodothyronine, the higher your metabolism. This is why people with fast metabolism tend to have more testosterone on average and gain muscle super easily. Moving on. What effects does testosterone have on the human body? As mentioned earlier, testosterone is a hormone. A hormone conveys messages to cells about what they should do. It controls the cell. The question is, what effect does testosterone have on our body? What message does this hormone convey to the cell? To answer this question, you need to understand the role of testosterone well. According to many experts, including Joe Herbert, a PhD in neuroscience at Cambridge University, testosterone has only one primary function, and that is reproduction. However, to make reproduction possible, many requirements are needed. Things such as fertility, attractiveness, and the ability to fight and win. Since all these things are necessary for reproduction, and testosterone is responsible for enabling reproduction in humans, testosterone essentially boosts all these aspects. For example, testosterone ensures that your body produces more muscle mass, making it easier for you to win a fight and mate with a female. Or, testosterone leads to the production of androstenedione, which is a pheromone. Pheromones are substances transmitted through the air and serve as a kind of natural perfume. Most pheromones are released through the air when individuals sweat. It appears that when women perceive the pheromone androstenedione through their sense of smell, their focus, mood, and sexual desires increase significantly. Mentally, testosterone also has many effects, as Joe Herbert explains. Testosterone also activates the essential mindsets needed to reproduce successfully, such as the inclination to compete with other men, the will to win, the strength to bond with other men to create cohesive groups to defend society and attack other societies. Modern human society is therefore designed to control testosterone through laws, religion, and even manners. Additionally, testosterone can even reduce a person's level of empathy. This could be useful for a man on a warpath, as it may facilitate the slaughter of everyone except women, thus ensuring reproduction. It is also suggested that testosterone can have such significant mental effects that it can influence a person's political preferences. In a 2011 study involving 136 men, some remarkable discoveries were made. Men were injected with testosterone, and it was found that men who had little to do with Democrats in the United States had 19% more testosterone in their blood. When these Democrats received a dose of synthetic testosterone, they were found to be 12% less committed to Democratic ideals and 45% more inclined to vote Republican. This study found that when men were injected with testosterone, they tended to lean more toward conservative voting than progressive. All these elements come together and have significant effects on a person. Just look at how much boys change between the ages of 12 and 18. Besides growing taller, all their other bones grow, they gain muscle mass, vertical height, their clavicles laterally lengthen, their ribcage grows in size, their blood pressure becomes higher than that of a female of the same age, their voices deepen, they develop facial hair, become more aggressive, rebellious, and tend to be less obedient. Many people have unusual habits to increase their testosterone levels for the benefits of this hormone. For instance, I recently came across an article on www.menshealth.com. In this article, a man was highly interested in optimizing his own biology, such as his body and brain. Since testosterone is central to these ideals, he began studying this hormone. He also delved into the benefits of UV light on the genitals. To his surprise, several scientific studies had already demonstrated that light on the gonads has various effects. In a study from 1939, it was found that exposing your gonads to light can boost testosterone by as much as 200%. This is attributed to the red light contained in sunlight, as this type of light stimulates ATP production, which is like gasoline for the human body. So, more ATP in your gonads should ensure they have more energy to produce testosterone. The person in the article decided to buy a special lamp that emits this type of light and shone it on his testicles. The result was a threefold increase in his testosterone levels. While this is highly impractical, it demonstrates how important this hormone is and how far people are willing to go to obtain it. Athletes and bodybuilders may be the group of people who most actively pursue this hormone, mainly because testosterone increases muscle mass, strength, endurance, fat burning, and recovery from intense efforts. In the sports world, where the smallest millisecond or the slightest increase in strength can make all the difference, these individuals go to great lengths to improve their bodies, and testosterone is a major factor. In top-tier bodybuilding competitions, it's almost a given that everyone competing injects a form of testosterone into their bodies. Arnold Schwarzenegger, an 8-time winner of the Mr. Olympia competition, stated that he injected 100 milligrams of testosterone into his body each week. This testosterone was synthetic and laboratory-made, rather than produced in his own body. If you don't use testosterone or an equivalent form of it, you simply can't win. In almost every sport, athletes either inject or ingest testosterone. Based on a review of studies, experts estimate that approximately 14 to 39% of elite athletes have intentionally used doping, with most doping involving a form of testosterone. This makes sense when you realize that, for example, if you're an Olympic sprinter and know that all your competitors are using testosterone and benefiting from it, and the sport is determined by the smallest of milliseconds, testosterone can make that crucial difference. You can reasonably assume that most Olympic sprinters inject testosterone, even Usain Bolt. Otherwise, you simply cannot compete with the competition. They are just not caught because there are people in laboratories figuring out how to best circumvent the tests. How to increase your testosterone levels? Naturally. Increasing testosterone levels naturally has no downsides, unlike injecting the hormone. With natural methods, you can enjoy all the benefits and no drawbacks. But how can you increase your testosterone levels without injections? First, you should revisit the previous chapter. How is testosterone produced in your body? In that chapter, we explored how testosterone is produced in your body. From there, you need to identify all the requirements needed for testosterone production. It's quite simple. If your body doesn't have the right materials to make testosterone, it can't produce it at all. So, what's the first step? Figure out what your body needs to produce testosterone. Cholesterol. Cholesterol is often viewed negatively because of some studies that demonized and associated it with heart disease. However, it serves as the foundation for the synthesis of all steroid hormones, including testosterone, and for some reason we see low testosterone with heart disease. The body is an amazing machine and is supposed to regulate hormones correctly, when being supplied with the proper nutrients. If so, we should focus on getting enough and the rest is taken care of. Cholesterol is obtained through your diet and is mainly synthesized in the liver within the body. As previously demonstrated, cholesterol is simply the precursor of testosterone. If there's no cholesterol in your body simply cannot produce testosterone. Therefore, it's wise to have enough cholesterol in your blood, which ironically, many people do not have. The best way to increase cholesterol is through your diet. Focus on consuming foods like egg yolks, liver, organ meats, and other animal products such as meat, fish, and dairy. Then after cholesterol has been provided and the amount in the body is sufficient, it is time to focus on the conversion of cholesterol into steroid hormones like testosterone. The conversion of cholesterol into testosterone is done by enzymes. These enzymes require luteinizing hormone and several minerals and vitamins. As mentioned earlier, magnesium is involved in more than 300 enzymatic processes. Some sources suggest it may be involved in well over 1,000. Magnesium is also involved in the production of luteinizing hormone, as is vitamin B6 and vitamin D, as we saw with the effects of solarizing the testicles directly from the previous article we mentioned. However, there are also nutrients that lower luteinizing hormone. For instance, fiber. Fiber has been shown to decrease levels of luteinizing hormone by 5%, which, let's be honest, most of what fiber does is so nullified on a big scale and easily replaceable that it's more of a problem. For example, it leads to increased feces, which, if you ask me, isn't really a good reason to be consuming a lot of it. Phytoestrogens. Certain plant compounds, such as phytoestrogens found in soy products, may have estrogenic effects in the body. High consumption of phytoestrogens could potentially affect LH levels indirectly by modulating estrogen signaling pathways. Although debated, heavily censored, and argued over by progressive media, it is no doubt that phytoestrogens affect luteinizing hormone negatively. Polyunsaturated fatty acids. This one is a big one. Omega-6 polyunsaturated fatty acids, PUFAs, found in some vegetable oils, influence hormone levels. Excessive intake of omega-6 PUFAs relative to omega-3 PUFAs has been associated with alterations in hormone balance, including decreased LH levels. PUFAs are a poison to avoid at all costs. PhD Raymond Peat, again, he is a pioneer, he will be mentioned over and over again, argues, besides increasing serotonin and decreasing thyroid, the PUFA are increased by estrogen, and they increase estrogen and have some directly estrogen-like effects. Certain medications, some medications, such as corticosteroids or opioids, may affect hormone levels, including LH. If you're taking medications that could influence hormone balance, get off that poison. When luteinizing hormone levels are at an adequate level, testosterone synthesis is reasonably well stimulated. There are several vitamins and minerals that play critical roles in the production of testosterone. Boron is the first one that comes to mind. Boron is a mineral responsible for many functions in the body. It extends the active duration of vitamin D in your body. We already know that vitamin D is essential for testosterone production, but apart from its effects, boron also lowers inflammation in the human body. In addition to all the previously mentioned benefits, boron has an enormous impact on testosterone. In one study, men who supplemented with 6 milligrams of boron per day for an entire week experienced a 40% increase in testosterone. You can obtain boron from foods like dried fruits such as raisins, prunes, apricots, and dates, avocados, and bee pollen. Some fruits such as apples, oranges, grapes, and pears contain boron, though the levels may vary. Nuts and seeds like almonds, peanuts, walnuts, sunflower seeds, and pumpkin seeds are all good sources of boron. Zinc is the next important mineral. Zinc is a cofactor for the enzymes required to convert prohormones into testosterone. Zinc is primarily found in many foods. A lot of people will recommend plant-based products. However, the bioavailability of zinc from plant-based sources may be lower compared to animal-based sources due to the presence of compounds like phytates, which can inhibit zinc absorption. So for foods that have bioavailable zinc, there's seafood. Oysters are one of the best sources of zinc, with other seafood like crab, lobster, and shrimp also containing significant amounts. Red meat, beef, lamb, and pork are particularly high in zinc. Poultry, chicken, and turkey are good sources of zinc, although watch out for tryptophan. Eggs. Eggs are a good source of zinc, particularly in the yolk. Vitamin D3, which many people don't know, is also produced from cholesterol, just like testosterone. Vitamin D3 is not only a vitamin, but also a hormone. We don't call it hormone D3 because we cannot live without it. Since vitamin D3 is produced from cholesterol using UV light, it's wise to get both into your system. For a long time, it was believed that people with dark skin could absorb less vitamin D because populations with generally dark skin tones often have low levels of vitamin D. Countries in Africa also score very low on the tests. This was believed to be linked to a person's skin color. The darker they were, the less vitamin D they would get. However, it doesn't appear to be entirely accurate. In a study with a group of people with various skin tones, exposure to UVB, the type of UV light that should stimulate the production of vitamin D, was tested. The amount of vitamin D a person would produce wasn't linked to their skin color, but rather the amount of cholesterol in their blood. This vitamin can also act as a hormone, and works by making the Leydig cells more sensitive to LH, which triggers testosterone production. This video primarily focused on nutritional patterns and their effect on testosterone levels in men, but didn't talk about the physical and mental aspects due to the fact it's gotten lengthy. Anyway, Primals, I'm afraid this video is coming to an inevitable end. If you enjoyed this video, smash that like button and leave some comments with your thoughts, feedback, and suggestions for future videos. Aesthetic Primal, out.